Key Management in Accumulo, and the speaker is Anthony Young-Garner from Cloudera.
Thanks very much. So Accumulo 1.6 introduced both encryption at rest and in transit, SSL, and then encryption on disk to protect against threats, actually, much like Cassandra alluded to, threats by parties who are within the realm of trust of the cluster, but who you might not trust with your specific data. So I want to talk a little bit about how that works in Accumulo 1.6, and then also I'm going to talk about how some features we added in base Hadoop in Hdfs address some of the same problems and how they might help solve the problem of key management, which isn't addressed by the encryption at rest solution in Accumulo 1.6. So I'll remind you that Michael Allen gave a talk last year on the encryption at rest in Accumulo 1.6, and I made some charts that brought back some characters that we saw as threat vectors in his talk last year. So we have our users, Sven and Joe, who are acting as clients to the Accumulo cluster, storing data in Accumulo, and they expect that as people inserting the data and retrieving the data, that data is private between those two clients. However, there's an implicit zone of trust inside of our Accumulo cluster such that network administrators like Molly or HDFS administrators like Halim might also be able to read the data that Sven and Joe are placing in the Accumulo cluster. Molly might see it as it traverses the network, and Halim might see it as it rests on the actual HDFS data nodes. Also, there is the threat of the Accumulo administrator. I won't address that here, but Cassandra set that up pretty nicely. So thanks for that. This threat is not theoretical at all. So here we see some data that is protected by visibility being accessed by a user who has permission to see that data. Here we see the HDFS administrator using standard HDFS commands to copy the R file directly off of the secure Accumulo cluster to an insecure Accumulo cluster that he has control over. Once he's copied that file to the insecure cluster, he can do whatever he wants with that data. And here we see him doing that on the insecure cluster. So he's imported that table from the secure cluster to the insecure cluster, given himself the necessary authorizations for the visibilities indicated on the data, and now he can see this data. This takes seconds. So it's a true threat. Now, you'd hope that something like this would be caught by auditing policies. So both we at Cloudera and many other vendors, we sell tools that help you audit accesses to your data so that hopefully someone would at least be able to catch after the fact that the HDFS administrator had done this. But if you don't have those audits in place, or if your HDFS administrator is sophisticated enough to subvert those audits, you might not catch that this had ever happened. Even if you do have the audits in place, the damage has already been done. So that is a problem as well. So again, in Accumulo 1.6, we introduced encryption in transit and at rest. So we see there the locks as the data traverses from the client machines to the cluster. We also see there that the locks indicating that the data is secure on the cluster, the HDFS cluster at rest. Implicitly, that also secures the data as it moves from the Accumulo cluster to the HDFS cluster. That's maybe not made explicit, but it's implied there because the encryption happens on the client side before it goes to the data node. The Accumulo solution introduced in 1.6 relies on the secret key encryption strategy. This is an interface, a Java interface that was introduced in Accumulo 1.6 that allows you to specify how the key used to encrypt the data encryption key, protecting the Accumulo data, should be stored. The default implementation of that stores the key encryption key on HDFS. Now, if you think about that for a second, that doesn't really solve your problem because we're protecting from the HDFS administrator administrator by storing the key encryption key for the data that we just encrypted in Hdfs. So that's somewhat problematic. I'm not going to go into a lot of detail about that scenario because Michael explained it quite clearly last year, and he gave a great talk. So I would recommend you go and look at the archives from last year if you wanted to hear more about that part of the solution. Just a little bit about how you set that up. So it's really, really simple to enable the encryption in Accumulo. You simply specify your key encryption strategy class. Again, this is what's going to decide how you store the key encryption key. And you also specify which algorithms you prefer to use. There are some not defaults, but recommended algorithms to be used in the documentation. Once you have enabled encryption, if the same attack vector was attempted by the Hdfs administrator, you see that he still can copy the data from the secure cluster to the insecure cluster. However, his attempt to actually scan that data fails because although he can import the R file, the file is not readable by the Accumulo runtime. Okay, so I went through those threats kind of quickly because, again, we have covered them in a previous talk. But here we're using visibility labels to protect against unauthorized users. So these are users within the Accumulo system. We're using SSL to protect against a network administrator. We're using Accumulo encryption at rest to protect against the threat of the Hdfs administrator. And then all of these, generally, there's the problem of misconfiguration. So security means nothing if you don't know how to use it properly. And so that is just a threat vector we always have to consider. So as I mentioned, the key encryption key is what's protecting all of the data that's encrypted in the Accumulo encryption at rest solution. And again, if we're storing that key encryption key on Hdfs, then we can just copy that key encryption key now to the insecure cluster as well, and we've once again got back to the same place. So Halim is much harder to thwart than we might think. Right. So here we're just right back to where we started. We've now added the cost of encryption over the wire. We've added the cost of encryption on the disk. And now Halim has copied the key to his insecure cluster, and he continued to do all the same things he was doing before. This is problematic. What I have worked on since I've come into the Hadoop ecosystem, which was just about almost a year ago when Cloudera acquired the company that I work for, is I worked for in Hdfs transparent encryption at rest. So Accumulo introduced encryption at rest before base Hdfs did, but last summer in Hadoop 2.6, we did release Hdfs transparent encryption at rest. So this is a little bit lower level than at the Accumulo level, but it's the same conceptually. It's the same idea. The client is encrypting data before storing it in Hdfs. This provides security over the wire between the client and the Hdfs data node. This also provides security or privacy of the data on the disk or on the data node. This prevents attacks at the Hdfs level, at the local file system level, and at the OS level. One key piece that we addressed in the Hdfs encryption solution is that we do address key management. So along with introducing Hdfs transparent encryption of data at rest, we introduced the Hadoop KMS, the key management service. The Hadoop KMS provides a proxy and an interface by which we can specify how keys should be stored and used by Hdfs encryption, and then also by any participants in the Hadoop ecosystem. So other services besides Hdfs can make use of the Hadoop KMS, and that is our intent, that other services besides Hdfs make use of the KMS. Today, the primary user is the Hdfs encryption subsystem. The KMS I'm going to talk in a little bit more detail about, but one key thing to take away on this chart, at least, is that the KMS does not itself store keys. It is just a proxy between the Hadoop ecosystem, or the Hadoop services, and some other backing key manager. But it does provide a great deal of value, both in terms of qualities of service and because its administration model and its API are designed with the Hadoop ecosystem in mind, in a way that most key managers are not. So I'm going to talk in only a little bit of detail about HDFS or encryption. If there are questions about it afterwards, I'm willing to talk to you in as much detail about it as you would like. But for the purposes of the talk, I don't want to spend too much time on it because it is somewhat complicated. But I'm going to give you the simple version now. And in both the charts and if you want to talk after, we can go into as much detail as you like. So the simple version is that you remember that we're protecting files on that HDFS data node in the center of the screen. We're protecting those files with data encryption keys. Each file has a data encryption key that's protecting it. The data encryption keys themselves are protected by a key encryption key. That key encryption key now is being stored in a key manager by the KMS. So it's kind of transparent to the Hadoop services what that backend key manager is. It interacts with that key manager through the KMS. That key encryption key is created by a user or by some service process. That's an entirely separate transaction from any of the encryption operations happening in HDFS. So from a sort of a life cycle point of view, the work with that key encryption key, that's that number one there, the work with that key encryption key happens on an entirely separate life cycle from any of the actual HDFS data. The HDFS administrator associates the key encryption key with an encryption zone. An encryption zone is simply a directory. Anywhere from the root directory down to any level below the root directory, you can specify an encryption zone. Everything within that directory or its subdirectories then will be within the zone. That association does not require the HDFS administrator to know anything besides the name of the key. So he still has no access to the key material on the KMS or elsewhere. All he knows is that the user of this directory has asked that he associate this directory with an encryption zone, and that encryption zone be associated with this key encryption key. When the user or a client process interacts with an encryption zone that he has permission to read and or write, the HDFS subsystem transparently will fetch from the name node metadata the name of the key and send it back to the client, and the client then will fetch the key from the KMS directly. So all encryption and decryption happens on the client side, never on the server or on the name node. So this prevents the HDFS administrator or anyone on the network or anyone who has access to the name node from getting access to encrypted data. The next two slides go into more detail about that, and I'm leaving them there kind of for your reference if you want to go back and look at this. I'm not going to cover these slides in the presentation. If you do want to talk about them after, we can do so. Okay, so I talked about the KMS as being the proxy between these services, the HDFS encryption services in particular, and the backend key manager. What's going on in this KMS? It's a proxy. That's its main job, and most key managers aren't meant to handle the kind of load that would come at them from the size of Hadoop clusters that people are running in production. So that's its main sort of operational purpose, is to serve as a proxy and throttle that incoming series of requests. It does some caching, it does quite a number of things to throttle incoming requests that would normally just hit the key manager directly. That's sort of the primary operational purpose. Also, it provides a unified API so that we can support multiple key managers. So anyone can implement that API to support any key manager that they might want to support in the future. The default implementation is a Java key store. On the one hand, that's really simple. On the other hand, as you can probably easily convince yourself, that doesn't solve a whole lot of problems for you, and I'll talk more about that in just a moment. It does provide like a lot of the Hadoop services, it provides a command line client that gives you simple lifecycle management for creating keys, rolling keys, deleting keys, the things you might expect. Also provides a broad set of access control capabilities. And again, these ACLs are oriented at the kinds of operations that are going to happen in the Hadoop ecosystem. So that's kind of a nice thing that sort of a standalone key manager wouldn't have, and the KMS provides that in front of your key manager. Oh, I should mention this. I've got it highlighted and don't even talk about it. So the HSM is something that's used in a lot of really secure environments. So folks use key managers, and then they also might have something called a hardware security module. Key managers that support a hardware security module, or environments that require a hardware security module, will insist that the root of trust for keys be placed in that HSM. The model that we have with the KMS as a proxy does allow you to respect that requirement in the environments where it's necessary. This is an example here of how ACLs are set. ACLs are set in this kms-accls.xml file. Looks like a lot of Hadoop configuration files that you've seen before. One note, this ACL file particularly is read dynamically. So if you change the ACLs, they do change at runtime. You don't need to restart the service. Okay, so here now we are storing our key encryption key from Accumulo encryption at rest on a Hdfs encryption zone that is now encrypted by a key backed by the Hadoop KMS. And now when our Hdfs administrator attempts to copy that key encryption key, he doesn't have access to that encryption zone. And because the Hdfs encryption understands what's happening, it gives a clear error message rather than showing you gobbledygook on the screen, because the Hdfs encryption subsystem does understand that the user can't access the key in KMS and just gives you back an error rather than even trying to show you the data. So it looks like we're pretty close to solving our problem now of giving you a way to not only encrypt the data, but also a way to protect that key. Anybody see something wrong with this? Okay, but there is something wrong with this. If you think about what the Hdfs administrator does, it's part of his job to copy files around. And so if you tell him now he can't do that, then he might say, well, what am I doing here? And then he's going to say, well, you need to give me access to the keys. So in building HDFS encryption, we've added a virtual path called reserved raw. The reserved raw path gives the HDFS administrator the permission still to move files around, to do his actual operations on the HDFS file system, but only with the raw data. It's still encrypted. He can never decrypt it. He can just move the encrypted data around. And so this lets the HDFS administrator still do his job without giving him access to any of the secrets that we might want to protect from him. Okay, so given that we have this new solution of HDFS encryption, we have now some options about how to sort of complete our picture of encryption in the Accumulo environment. So one option, this is the one that I just showed, was to protect the key encryption key itself. Another option then is to decide to protect the entire Accumulo database, and I'll talk a little bit about pros and cons here, and then still we can implement a custom strategy that sort of combines the best of both worlds. So the example I just showed then was using now the HDFS encryption zone to protect the Accumulo key encryption key. So what I'm showing there with that orange block is that the key, unlike the other data that's on the HDFS cluster, is being protected not by the client-side trust between Accumulo and the HDFS cluster, but by the KMS. The key there is being protected by the KMS. Because the HDFS administrator doesn't have access to the key within the KMS, he is outside the implicit zone of trust. The way that you actually do that procedurally is what I'm showing here, and I only show it here to show that it's really pretty simple. We create an encryption zone in this, we create a key in this first command. The Accumulo user does that. Then we have our directory where we're going to store this key. So here we have the Accumulo crypto secret that we're going to move to Accumulo crypto secret temp. The reason we're doing this move is just a kind of a procedural detail, is that you can only create an encryption zone in an empty directory. So if you already have data in the directory, you can't create an encryption zone there. So data that you want to encrypt, you either have to move it or copy it somewhere else in order to affect the actual encryption operation. So in this case, we're moving the secret aside for a moment so that we can encrypt the empty secret directory and then move the data back. That's what we're doing here. Once we've done that, we can have the Hdfs administrator create an encryption zone. That's right there in the middle of the screen. Once he's created that encryption zone, that secret then is protected as the key is stored there. So literally, those are the only commands required. So that's kind of why I put them on the screen. It's really, really simple to do this. So that's one of the great advantages of this approach. It's the least effort path forward with minimal operational risk or downtime. You really would need, the only downtime on your cluster would be the time it took to run those commands, which you could do theoretically in a minute or two. If you're already using Accumulo encryption, this is also sort of the easiest path forward. It requires you to have the least understanding of other subsystems or even the Hdfs encryption or the KMS. You're just making minimal use of those new systems. So this allows kind of a general adoption of Hdfs encryption or KMS and still lets you leverage all the administrative capabilities of the key management service. One downside of going in this method, if you're not already using Accumulo encryption, is that the Accumulo 1.6, at least, encryption is not quite complete. So the R files and the write-ahead logs are encrypted, but if a tablet server fails, then there are recovered write-ahead logs, and those today are not encrypted by Accumulo encryption at rest. Also, and I will ask audience members to correct me on this, but as I understand it, the current implementation is considered experimental, and so I don't know what the official what that officially means, but I assume that means you're not going to want to use it in production. So that's sort of a trade-off there. But it really is the easiest path forward if you just want to kind of see how this can work. Another option is to protect the Accumulo directory directly. So here we are actually encrypting the entire Accumulo database with Hdfs encryption. This is a little bit simpler sort of operationally because you're not having two types of encryption going on, you're just using one encryption subsystem. But it is a much larger change because now you've moved like really all the infrastructure of your database to a new subsystem that you may not be familiar with, and you may or may not want to do that. But the steps are the same. So in the same way, you just copy a directory, which is in this case your Accumulo data directory. This is also, again, operationally quite simple. You're just moving your Accumulo data directory. Now, here I'm kind of stealing a base because moving that directory, depending on how large it is, that could take quite a while. Also, you're going to want to know what your performance characteristics are once you've moved your Accumulo directory into the Hdfs encryption zone. So as you might imagine, performing transparent encryption and decryption on your entire database is going to introduce a performance overhead. And we have done some benchmarking, but really the only way to know for sure what that amount is going to be is to do some testing. So you're going to have more downtime doing it this way because you're going to need to do some testing and make sure you still can meet your SLAs before you move your system back into full operation. But what's nice about this is that we do fully support Hdfs encryption in production today and the KMS in production today, so you do have that advantage. That said, there's real life, right? So we support Hdfs encryption in production today. We support KMS in production today. However, these were both just released last summer, so this is relatively new. That, to me, spells that there is some operational risk. And so I use the example of HBase. So we have seen real-life workloads now running on HBase in the Hdfs encryption subsystem, and we have seen bugs. The system is not perfect, and we've had to make some changes because of us in Hdfs land affecting the performance of HBase negatively. We fixed these bugs. That's good, but it's quite a possibility that as the first people trying this on Accumulo, you will find new things that we didn't find yet. So it's supported in production, but it's new. So there's always that sort of caveat. To me, even though I talked about the last approach is considered experimental, you're moving a whole lot less into a new subsystem. So in that sense, you could have, somewhat more confidence that your system's going to operate the way that it did before. Another option that's still available is to implement the secret key encryption strategy itself. So the secret key encryption strategy is a Java interface. You can implement the API. This could give you a tighter connection to the core capabilities in Accumulo. It also will let you give it a tighter connection to the Accumulo release cycle. So Hdfs encryption is releasing on an Hdfs release cycle. Accumulo encryption is going to continue to release on an Accumulo release cycle. If you want to stay more tightly tied to the Accumulo release cycle, you might find it more comforting to implement that interface. You could still then support arbitrary key servers. The trouble with that is, in general, I think all of us who've worked in any detail on encryption or key management will tell you that it's easy to get the details wrong. So deciding to implement the API yourself, I'm not going to say that it's not the wrong thing to do, but it's definitely something you want to truly consider before you take that on, and then you're going to have to maintain it over time. Okay, so then that's really what I wanted to present to you today. Just some solutions to key management that we're offering now through the Hdfs encryption subsystem, and then also how you might use Hdfs encryption to solve your general data at rest encryption problem in Accumulo. And I'll open for questions now. Yes, so the question was, in the time between when you move your key encryption key from the unprotected space to the encryption zone, it's available and can be stolen. Understood. So the two parts of that question then. One is that a threat vector? And the answer to that is totally yes, that's a threat vector. The second part of the question is, do we have any protections in place to make sure that once we move data into an encryption zone that it truly is gone from everywhere else? And the answer to that is also yes. If you actually do a move of data to an encryption zone, yes, I can go into a lot more detail about that, but the answer is yes, that we are aware of that vector and we protect against it. In general, the best case is that you'd want to create the key encryption key in the encryption zone in the first place. I'm sort of starting from the assumption that you already have Accumulo encryption in place and there's a key that's not being protected. But if that isn't the case, you would want to start with the encryption zone first and then actually create the key there in the first place. If you could, that would be the best of all worlds. Any other questions? All right, thank you very much for your time.